Welcome to this physics problem involving projectile motion. Let's analyze a scenario where two stones encounter each other in midair. Here's our problem. A stone is dropped from a captive balloon at an elevation of 1,000 feet. 2 seconds later, another stone is projected vertically upward from the ground with a velocity of 248 feet per second. If g is 32 feet per second squared, when and where will the stones pass each other? Let's visualize this scenario. We have a balloon at a height of 1,000 feet, from which the first stone is dropped at time t equals 0. This stone falls downward under the influence of gravity. Then, at time t equals 2 seconds, a second stone is projected upward from the ground with an initial velocity of 248 feet per second. We want to find when and where these two stones pass each other. To solve this problem, we need to set up equations for the heights of both stones as functions of time. Let's define t as the time in seconds elapsed since the first stone was dropped. For stone 1, we use the equation of motion for an object under constant acceleration. The height of stone 1 at time t is given by h1 of t equals 1,000 minus 1/2 times 32 times t squared, which simplifies to 1,000 minus 16t squared. For stone 2, we need to account for the fact that it's launched at t equals 2 seconds with an initial velocity. The time that stone 2 has been in motion is t minus 2. Using the equation for the position of an object with initial velocity and constant acceleration, we get h2 of t equals 248 times t minus 2 minus 1/2 times 32 times t minus 2 squared. This simplifies to 248 times t minus 2 minus 16 times t minus 2 squared. Let's visualize how these two stones move. Stone 1 starts at 1,000 feet and falls downward, while stone 2 starts at the ground at t equals 2 seconds and moves upward. At some point, these stones will pass each other. To find when and where the stones pass each other, we need to find the time when both stones are at the same height. That means we set h1 of t equal to h2 of t and solve for t. 1,000 minus 16t squared equals 248 times t minus 2 minus 16 times t minus 2 squared. Let's expand this equation. First, we expand the right side. 248 times t minus 2 is equal to 248t minus 496. And t minus 2 squared equals t squared minus 4t plus 4. Continuing with our expansion. 248 times t minus 2 minus 16 times t minus 2 squared equals 248t minus 496 minus 16 times t squared minus 4t plus 4. Which equals 248t minus 496 minus 16t squared plus 64t minus 64, which simplifies to negative 16t squared plus 312t minus 560. So our equation becomes 1,000 minus 16t squared equals negative 16t squared plus 312t minus 560. Let's solve this equation. We can combine like terms and simplify. First, we combine the t squared terms on both sides. 1,000 minus 16t squared plus 16t squared equals 312t minus 560, which simplifies to 1,000 equals 312t minus 560. Adding 560 to both sides. 1,000 plus 560 equals 312t, so 1,560 equals 312t. Dividing both sides by 312, t equals 1,560 divided by 312, which equals 5. So the stones pass each other after 5 seconds. Now that we know when the stones pass each other, let's find the height at which this occurs. We can substitute t equals 5 into either of our height equations. Let's use the equation for stone 1. h1 of 5 equals 1,000 minus 16 times 5 squared. Equals 1,000 minus 16 times 25 equals 1,000 minus 400 equals 600 feet. So, the stones pass each other 5 seconds after the first stone is dropped at a height of 600 feet above the ground. Let's visualize our solution with a final animation showing both stones meeting at exactly 5 seconds at a height of 600 feet.